Today we will solve more trig equations, including multiple angle equations. For number 1, solve for all possible solutions. For this particular equation, we have one sine term, one cosine term, and no other terms. In this specific situation only, we can use the quotient identity that tan x is equal to sine x over cosine x by dividing both sides by cosine x. We are not usually allowed to divide both sides by a variable because we'd be losing a solution. You can see in the algebra example shown that if we divide both sides by x, we will not get the solution x equals 0 like we do when we correctly solve by factoring and zero product property. But when we divide both sides by cosine x, we are not reducing cosine x on both sides. We are simply using inverse operations to allow us to use the quotient identity. See how cosine x over cosine x didn't get reduced to be 1 on both sides, only on one side. I divided both sides by root 3, rationalized the fraction 1 over root 3, and changed sine x over cosine x into tan x. The angle for which tangent is root 3 over 3 is pi over 6 plus pi n, because the natural period of tangent is pi. The other solution between 0 and 2 pi is 7 pi over 6, but we do not need to write an additional expression because when we plug in 1 for n into this expression, we get 7 pi over 6. Therefore, this single expression encompasses all possible solutions. For number 2, find all solutions on the interval 0 to 2 pi. In this case, we do not have only one sine term and one cosine term. We also have a constant term. So in this case, we cannot solve by dividing both sides by cosine x. In order to relate cosine x and sine x in this case, we'll need to use a Pythagorean identity. But to do that, we need sine or cosine to be squared. So, in order to make them squared, we'll square both sides of the equation. Expand the left side and rewrite the right side, sine squared x, as 1 minus cosine squared x. Now bring everything to one side and factor. Use zero product property to solve for cosine x. Cosine x is 0 when x is pi halves or 3 pi halves, and cosine x equals -1 when x equals pi. Super important! Remember when we were solving square root equations and we squared both sides? We had to check for extraneous solutions because squaring both sides can provide additional solutions that are not true solutions of the original equation. So if we square both sides, we must check for extraneous solutions. Because 1 does not equal -1, 3 pi halves is an example of an extraneous solution. But pi halves and pi are true solutions of the original equation on the interval 0 to 2 pi. So those are my only answers. For number 3, we have a multiple angle equation, 2 sine of 3x minus 1 equals 0. To make it easier to visualize, let theta equals 3x. And now solve for theta. Sine theta equals 1/2 means that theta is equal to pi over 6 plus 2 pi and 5 pi over 6 plus 2 pi. This is our 4th time solving for sine theta equals 1/2 in the last 2 videos. Now plug in 3x for theta and isolate x. Therefore, x is equal to pi over 18 plus 2 pi n over 3, or 2 pi thirds n, and x is equal to 5 pi over 18 plus 2 pi thirds n. To find the specific solutions on the interval 0 to 2 pi, we'll need to use the expressions we created and plug in various integers beginning with 0. When n is equal to 0, our first expression gives us the answer pi over 18, and our second gives us 5 pi over 18. But we have more answers between 0 and 2 pi. When n equals 1, plug in 1 for both expressions and simplify. X is equal to 13 pi over 18 and 17 pi over 18. When we plug in n equals 2, we get 2 more answers. (25 pi over 18 and 29 pi over 18. Try plugging in n equals 3. The interval for which we're looking for solutions is 0 to 2 pi, but if I'm taking pi over 18 and adding 2 pi, that's definitely greater than 2 pi. So n equals 3 does not give us any more solutions on our interval 0 to 2 pi. Therefore, all the solutions on the interval 0 to 2 pi are pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. Try number 4 on your own and press play to check. Remember, the period of tan is pi, so we only need one expression to encompass all solutions. When plugging in n equals 0, x is pi thirds. When plugging in n equals 1, x is 7 pi thirds. But plugging in n equals 2 gives you a solution outside the interval 0 to 4 pi, so we only have 2 specific solutions on the interval 0 to 4 pi.